Hello students, welcome to my YouTube channel DR Mathematics and also welcome to the chapter of function. In this particular session we are going to discuss about the domain of a function, range of a function, codomain of a function and then equal functions and real value function and real functions and some of the problems based upon these fundamentals. So let us start this video from the domain, codomain and range of a function. If f is a function from the set A to the set V, then the first set A, the total first set A, all the elements are called as the domain of the function. That means domain of f is equal to A. Then the second set V is called the codomain of the function. That means f. That means the codomain of f is equal to V. Then the range of the function is a special type of fundamental here. It is defined as f of A. That means all the f images of the elements of the first set which are defined by f of A such that the first element belongs to the first set. Then their images are called as the range of the function, and then range f is called as or it is denoted by f of A. And let us discuss about an example based upon this domain, codomain and range of a function. And the example is like this. Here the first set A is given to you -2, -1, 0, 1, 2, and then B is defined as 0, 1, 2, 3, 4, 5, 6. And f is a function which is defined as from the set A to the set V as like f of x is equal to x square. That means we have to use this condition and then we have to find out the function here, and from the function we have to find out the domain, codomain and the range. So here it is the solution. Given that A set is equal to -2, -1, 0, 1, 2 and B set is defined as 0, 1, 2, 3, 4, 5, 6. F is a function from A to B defined by f of x is equal to x square. Then we have to find out first of all the function here from the set A to the set V. So here it is the first set defined by -2, -1, 0, 1, 2 and the second set is 0, 1, 2, 3, 4, 5, 6. And we have to find out the function f here by the given condition f of x is equal to x square. That means square of -2 it is 4. Square of -1 it is 1, square of 0 it is 0, then square of 1 it is 1, then square of 2 again it is 0. So the function f is defined as -2, 4, -1, 1, 0, 0 and then 1, 1 and then at last 2, 4. And here we have to find out the domain of the function y. The notation domain f, and domain f is the set of all first components of the given order pairs or of 10th order pairs. So it is -2, -1, 0, 1, 2. And from here you can see that the domain of the function f is equal to the first set. Then codomain, as per the definition, codomain of the function is equal to the second set. And then we have to find out the range of the function. Range f is defined as 0, 1, 4. The set of second elements from the of-10th order pairs. So it is all about the domain of a function, range of a function and codomain of a function. After this fundamental, we are going to proceed the function topic towards to the fundamental of equal function. Let us discuss about equal function and basic example based upon the equal function. Then let us discuss about the topic equal function. Let us consider two functions f and g, and we have to show that the two functions f and g are equal with each other. That means the function f and g are equal functions. There are three conditions to satisfy the function f and g are equal with each other. The first one is here, domain of the function f must be equal to the domain of the function g. then codomain of the function f must be equal to the codomain of the function g. And then at last the very vital part is here, f of x must be equal to g of x. It is the condition for the range of the two functions. F of x must be equal to g of x for every x belonging to their common domain. And let us solve a problem which is based upon the equal function. The two sets A and B are given to you. A set containing the elements 1, 2 and B set containing the elements 3, 6. F is a function from A to B is given by f of x is equal to x square plus 2. Another function g is there which is defined also from A set to B set, which is given by g of x is equal to 3 of x. So first of all we have to find out f of 1. F of 1 is equal to 1 square plus 2 which is equal to 3. Then f of 2, 2 square plus 2 which is equal to 6. Then we have to find out g of 1 and g of 2. G of 1, it is 3 multiplied with 1, that is 3. G of 2, it is 3 multiplied with 2, it is 6. From here you can see that the domain of the function is very much equal to the range of the function, which is equal to 1, 2. Obviously domain of f is equal to domain of g. Domain of the function f is very much equal to domain of the function g, which is equal to a. Then codomain of the function f is equal to codomain of the function g, which is equal to v. Then at last the very vital part, as I have already told, we have to show that f of x is equal to g of x for every x belonging to their common domain. Here you can see that f of 1 is equal to g of 1 and it is equal to 3. Then f of 2 equal to g of 2 which is equal to 6. So f is equal to g, that means the two functions f and g are two equal functions. So it is the completion of equal function. Then let us discuss about some of the problems based upon these fundamentals. So these are the two problems I have taken here. So let us solve the first example. A function f is defined by, given that the function f is defined by f of x is equal to 2x minus 3. Then we have to define or find out the value of f of 0. That means we have to put 0 in place of x, then f of 5 and then next f of minus 2. So f of 0, it is 2 multiplied with 0 minus 3, that means it is minus 3. Then in second bit f of 5, it is 2 multiplied with 5 minus 3, that means it is equal to 7. Then in the third f of minus 2, which is 2 multiplied with minus 2 minus 3, it is minus 7. So this is the solution of the first example. Then proceeding towards to the second example. Given that f is equal to the set of order pairs minus 1 minus 3, 0 minus 1 and then 1 1 and then 2 3. And here it is also given that f is a linear function. Let the function f is given by f is equal to ax plus b, which is the general form of the linear polynomial. Okay, let us write down f of x is equal to ax plus b, and let us consider it as equation number 1. Let us put this order of where 0 minus 1 by applying the condition f of x is equal to ax plus b. F of 0 is equal to minus 1. F of 0, it is equal to minus 1 because minus 1 is the f image of 0. So by putting 0 here, we can have a multiplied with 0 plus b is equal to minus 1. That means b is equal to minus 1. Then again let us consider this order pair 1 1. 1 is the f image of this one. So f of 1 is equal to 1. That means in place of x we have to put 1 here. It is a plus b is equal to 1, because all of you know that the value of b is minus 1. So it is a plus minus 1, it is 1. That means a is equal to 2. So here we have evaluated the values of a and b. Now we have to again consider this function f of x, and we have to write down the required linear function here. We know that f of x is equal to ax plus b. That implies by putting the values of a and b here, f of x is equal to 2x minus 1, which is the required linear function. So here it is all about the solution of the problem number 2 or example number 2. Then let us move towards the very important section of this function topic, that is real function and real valued function. Now let us consider about the real function and real valued function. What is real function and what is real valued function? If both the domain and range of a function is a subset of the real number, that means the subset of R, then it is called as a real function. If the necessary condition in the real valued function, if the range of the function is the subset of the real number, then it is called as a real valued function. Not the domain. The necessary condition is here, the range of the function must be subset of R, then it is called as a real valued function. And also very important, all the real valued functions are not real functions. Some of the real valued functions are there which are not real functions, and some of the real valued functions are there which are real functions. Now let us consider about or discuss about one of the example based upon the real function and another example based upon the real valued function. So let us consider the function f of x is equal to x square plus 1, where x belongs to R. That means we have already taken the domain is subset of R, because x belongs to the domain part. Here it is x part, and here we are getting f of x. Okay, so let us put f of 1, then it is 1 square plus 1, that means it is 2. Let us put 3, then it is 3 square plus 1, that means it is 10. Let us put a fractional number 1 by 2, then it is whole square of 1 by 2 plus 1, that means it is 1 by 4 plus 1, it is 5 by 4. So we are obtaining a real number in the range part whenever we are putting the real number from the domain part. That means the domain is subset of R, and as well as the range is subset of R. Hence this function is a real function. So f of x is a real function. Then let us discuss about the real valued function. Let us consider the two sets. Suppose A is here containing the elements Ram, Shyam and Hari, and V is set which contains the roll numbers of these students, and the function A to be defined by, suppose the roll number of Ram is 1, the roll number of Shyam is 3, and the roll number of Hari, it is 5. It is the F image. 1 is the roll number of Ram under the function f. That means 1 is the f of x and Ram is the x. And here you can see that the domain contains 3 names, not numbers. So domain is not subset of the real number set, but you can say that the range here, the range is 1, 3, 5. All the three numbers are real numbers, and you can say that here a range is subset subset of R. But in case of domain, here domain is not subset of R because the domain contains three names. So here f is a real valued function. It cannot be a real function. Here f is a real valued function. Real valued function. So it is all about the examples based upon real function and as well as real valued function. So here I have taken some of the examples based upon these fundamentals that we have studied today and in this particular session, and let us solve these last two problems based upon this particular session. So here it is the solution of the first example. Given that f of x is equal to x square plus 4, then we have to find out f of x minus 1. That means we have to put x minus 1 or we have to substitute x minus 1 in place of x. Here also in the right hand side we have to substitute x minus 1 in place of x. So it is x square plus 1 minus 2x plus 4. So it is x square minus 2x plus 5. This is the simple answer for the example number 1. Then proceeding towards to the next one. Very easy. Just we have to substitute the value given the required value x minus 1 in place of x. As well as in the right hand side part also we have to substitute x minus 1 in place of x only. So let us move through the second problem. Given that f of x is equal to x plus 1 by x, then we have to prove that the whole cube of f of x is very much equal to sum of f of x cube plus 3 multiplied with f of 1 by x. There is a difference between whole cube of f of x and f of x cube. Whole cube f of x means we have to find out the cube of x plus 1 by x. But f of x cube means we have to substitute x cube in place of x. So let us move through the left hand side part. Whole cube of f of x, that means whole cube of or cube of x plus 1 by x, and it is very much equal to x cube plus 1 by x cube, then it is 3x square, then it is 3, okay, this is 3x, and then this is 3 of 1x, okay. Then we have to find out the sum of f of x cube and 3 multiplied with the f of 1 by x. Okay, first of all let us find out f of x cube. This is the term f of x cube. That means we have to substitute x cube in place of x. So here it is, we have substituted x cube in place of x. In the right hand side part we have to substitute x cube in place of x. Then again we have to substitute x cube in place of x. The x is remaining here in the denominator part. So we have to put x cube only in the place of denominator. In place of x we have to substitute x cube. Then let us move through the second term here. 3 multiplied with f of 1 by x. That means 3 multiplied with f of x, f of 1 by x. That means, okay, first of all let us find out f of 1 by x. Then we have to find out 3 multiplied with f of 1 by x. Okay, f of 1 by x means we have to substitute 1 by x in place of x. So here you can say that here lies x. So we have to substitute just 1 by x. Then we have to find out x here, and x is in the denominator part. So we have to substitute 1 by x in the denominator part. Just simplify this. This is 1 by x plus x. Then we have to find out 3 multiplied with f of 1 by x. So 3 multiplied with 1 by x plus x. So it is 3 by x plus 3x. Then we have to go through the right hand side part. Right hand side part is f of x cube plus 3 multiplied with f of 1 by x. Here we have evaluated f of x cube, that is x cube plus 1 by x cube. Then we have to put the value of a 3 multiplied with f of 1 by x, that means 3 by x plus 3x, and here you can see that this is the left hand side part and this is the right hand side part, and they are equal with each other, hence LHS is equal to RHS. So it is proved. So here it is all about the problems based upon this particular classes. So today in this particular session we have discussed about the domain, codomain, range of the function, and then we have discussed an example based upon the domain, codomain and range of the function. Then we have gone through the equal function and an example based upon the equal function. Then we have discussed very important real valued function and real function. What is the difference between the real function and real valued function, and some of the examples and basic examples that we have done today based upon this particular classes. In the next video session we are going to start the different types of real functions and their graphs and some of the examples. Till then, thank you.